So part A asks to write the first three non-zero terms and the general term of the Taylor series for sine of x minus 1 squared about x equals 1. So right now I'm just going to write down the Maclaurin series for sine of x. So from there, we're just going to shift our Maclaurin series of sine of x so that it's centered at x equals 1, which just means that we're going to subtract 1 from each x value that's in the Maclaurin series to get our new function. So we're going to shift the Taylor series once again, and this time we're going to take all of our x minus 1s in the function and we're just going to square each of them. So for example, for 1 over 3 factorial x minus 1 cubed, it's going to turn into 1 over 3 factorial x minus 1 to the 6th. So part B asks us to use the Taylor series found in part A to write the first three non-zero terms and the general term of the Taylor series about x equals 1. So first I'm just going to write down our f of x function. Then I'm just going to write down our sine of x minus 1 quantity squared Taylor series that we got in part A. Then we just take our Taylor series of sine of x minus 1 quantity squared and we divide the entire thing by x minus 1 squared. So basically all of the exponents that we have are going to go down by 2. Part C says to use the ratio test to find the interval of convergence for the Taylor series found in part B. So for a ratio test, what you do is you take the limit as n approaches infinity of the absolute value of a general term of a series to the n plus 1 power, and then multiply it by the reciprocal of the original general term. And for a ratio test to converge, we know that it has to be less than 1. Now we can start canceling things out. So our negative 1s are going to cancel out because it's an absolute value function. Then our x minus 1 to the 4n is going to cancel out because of the x minus 1 to the 4n plus 4 on top. And that leaves us with our factorials and our x minus 1 to the 4th. From there, we can rewrite our limit and get rid of our absolute value symbols and keep our factorials and our x minus 1 to the 4th. Now we can rewrite our limit one more time and get rid of our factorials. So the top 2n plus 1 factorial is going to cancel out because 2n plus 3 factorial is greater, leaving us with x minus 1 to the 4th over 2n plus 3 times 2n plus 2. Now we can evaluate our limit. So since there are no n's on the top and there are n's on the bottom, we know that the limit's going to equal 0. Since it doesn't matter what the x equals, and 0 will always be less than 1, this means that the interval of convergence is going to be all real numbers, or from negative infinity to infinity. And since we know that infinity and negative infinity are not real numbers, we use open parentheses when we consider the interval of convergence.